Okay, good morning, everybody. Welcome to day one of e-learning for anatomy. Today we are going to be reviewing muscle contraction, and then we are going to be talking about isotonic and isometric muscle contraction, and we have a little baby lab to do about isotonic and isometric muscle contraction. Um, for your bell work, so your bell work is a Google form, and that Google form has to be completed using your Heron High School email address. So, if you do not know your Heron High School email address, it should be first name dot last name @ heronhighschool.org. And if you don't know your password, you should email helpdesk@heronhighschool.org, and they will help you get that password reset so you can get into your email. So use your Heron email, fill out the Google form for the bell work. At the bottom of that, it has you upload your IP. You can take a photo of that using your phone and upload it. If you're having a hard time with that, you can also take a photo and email it to yourself and then upload it. Should be pretty straightforward. If you have questions, please email me. Second thing is I have office hours now with more Chester, so Chester will be making an appearance in office hours. Chester is currently looking out the window. But every day between 1 and 2 p.m. I have an office hour. You can find the link at the top of my Haiku page. It says virtual office hours. Click here when link is active. The link will be it'll turn a link color when it's active because I have to make a link every time. So come to my office hours, ask me questions. Happy to have you. Okay, so let's go over the bell work. So I asked you to look at the sarcomere here and then to identify by name the purple and green filaments. So if you remember or looked back at your notes from last class, the green filaments here are called myosin. It's the thick filament, it's myosin. And then the purple filaments, lost my mouse, there we go. Purple filaments here, these remember are called actin. So you're identifying actin and myosin, and then try to come up with a definition for each of the following. So if you look at the I band is this area here. Maybe not so much a definition, but if we're just observing it, we see that there is only actin in this space. Then if you look at the A band, so A band would be all of this space. That is where you have actin and myosin. And then if you look at the H band, which is just this space, you have only myosin. So when your sarcomere contracts, the A band gets shorter, and that is what makes your muscle contract. Review of muscle contraction steps. So this, I want you to be reviewing with your friends and your family members. Try to explain this to them. This is a really practice heavy unit, so you need to be out there trying to explain these steps to your friends so you makes them stick in your brain a little bit more. Feel free to use your notes to begin with, but try to get it so you can describe this without using your notes. So if we look at step 1, which this is a cycle, so it repeats, so you could really start at any point, but I like to start at the top of the circle. So we have ATP being hydrolyzed. Remember, that means it's getting split apart into an ADP, adenosine diphosphate, plus an extra phosphorus. And that releases a little bit of energy, and that little bit of energy is enough to let that myosin head grab onto actin. And it forms what's called a cross bridge. So this space here is a cross bridge. And then that ADP plus the phosphorus are bound to myosin as myosin head attaches to actin. We just said that. Number 3, so myosin head has bound. Then we kick the adenosine diphosphate, that ADP, off of that myosin head, and that releases enough energy to make what is called the power stroke. It releases enough energy to pull that actin or make the actin shorten. So you're pulling that actin, shortening those bands. And then number 4, that myosin is stuck on actin until a new ATP, adenosine triphosphate, shows up. When that new ATP shows up, then the myosin head can relax, ATP hydrolyzes, we start again. If you need more review, and I highly recommend watching this stuff again, this first video here, and these are both going to be linked on Haiku. So the first video is the 4-minute video of just that sarcomere model with the lady with the flower shirt contracting. So she's explaining that sarcomere model. You'll probably be able to hear it better on your own than you could when we were trying to watch it in class. And then the second video is the crash course intro to muscles. This talks about muscle contraction, and it goes more in depth than our very first explanation. It gets into more of like the troponin and tropomyosin, which we're going to touch more on next class, I believe. Okay. So today in class, muscle and fatigue, what are they? So muscle fatigue, what is it? Why might it happen? So think a moment. What do you think of when you think of the word fatigue? Maybe you think of somebody who looks tired, somebody who just can't stay awake. Maybe you think of maybe after you work out, your muscles feel really tired or like they get shaky. Or maybe you might think about at a molecular level, your muscle cells needing more acetylcholine, which is the neurotransmitter that allows calcium to be released into the muscle to allow for that contraction, and the neuron not being able to release more acetylcholine. So at a molecular level, it's fatigue is a lack of molecules that are needed for muscle contraction. So your neurons just can't provide them as fast as your muscle is contracting. That might lead to like that tiredness or those shaking muscles that won't contract properly. Isometric exercise and isotonic exercise. You may have heard of these, but these may be brand new words for you. So isotonic exercise or isotonic contraction is a contraction where you have the myofilaments, that just means actin and myosin, are successful in sliding movements. The muscle shortens, the movement occurs. So isotonic contractions are typically repetitions. Okay, so your muscle successfully contracts, it repeats. So if you're trying to fatigue your muscle with isotonic, you're doing many repetitions. So like push-ups would be an isotonic contraction. And then isometric contractions, those are resistance contractions. So your myosin myofilaments are skidding their wheels and the tension keeps increasing. So they're trying to contract, but they can't contract. So they're trying to move an object that's immobile. That is your resistance exercise. So that would be like a plank would be isometric, or anything where you're holding poses. So like yoga, most of that is isometric contractions. So review that. Isotonic are successful sarcomere contractions. Those sarcomeres shorten and lengthen and shorten and lengthen. And those are like repetitive exercises. So do many reps. And then isometric, the sarcomeres cannot contract completely. So they're trying to contract, but they can't. And this would be resistance training. So if we look at our 4 figures here, are they isometric or isotonic? We have a girl running. We have a side plank happening. We have some pushing of 2 hands together. And then we have some tennis. So take a moment, jot down, are they isometric or isotonic? Each one. Okay, so our runner here, she is isotonic, so she has many repetitions happening. Our side plank guy would be isometric because that's a resistance training. His muscles would be skidding against themselves, not able to contract fully. Lady here doing maybe it's a yoga pose, I don't really know. It's not like a yoga pose that I have ever done. But this would be an isometric. And then our tennis player would be isotonic, many repetitions, many muscles contracting. Okay, so now we have our lab. There is a separate video for the lab. It's linked down below, and it will give you an explanation of what you're doing in the lab, and also give you ideas for like how to complete the lab at home, because I know you might not have. It uses, in class we use a tennis ball, but I know you might not have a tennis ball, so it has some other ideas. So you are making your own data sheet for that. There are instructions, so please click on the instruction sheet. It has the post-lab questions on it. So instruction sheet you need to open, data sheet you can make. I have an example. Post-lab questions you are going to upload to the Google form. You're also going to upload your data tables. They can be it's all uploading documents. So that should be pretty easy. That Google form, remember, you're using your Heron High School email address. I want you to do both the isotonic and the isometric part of the lab because it's an interesting lab. I think you'll enjoy it. So submit those post-lab questions today. Yeah. For next time, your IP is muscle IP number 2. You use the reading titled Muscular Reading, Muscle Types, Contraction, Notes, and Crash Course video that is linked on Haiku for extra assistance. I will be posting keys for IPs. Hopefully, like, IP number 1 will go up, like, the day that it's due, which it's not up yet. And then IP number 2 will go up the day that it's due. That way you can check your work. Yeah, come to office hours. Every day, 1 to 2 p.m., ask me questions. I'm here for you. I hope that you are all healthy and well. I hope that you are not going too bonkers being stuck at home. But, you know, this is some public health stuff that's happening. So we want to make sure to minimize those infections, make sure that we give our healthcare system a good opportunity to be able to handle the COVID-19 crisis happening. Hope that you're well. Hope to see you soon. Come to office hours. Email me. I'm here for you. Bye.